an and bn are two real sequences, and we want to show that the limit infimum of an plus the limit infimum of bn is less than or equal to the limit infimum of the sum of an and bn, that is less than or equal to the limit infimum of an plus the limit supremum of bn. Because a and bn are of the same status, therefore you can just interchange, say, limit supremum of an plus the limit infimum of bn. It's the same thing, same meaning. So let's just quickly revisit the meaning and the concept of what it means by limsup and liminf, right? So first of all, we all know that as a real sequence, it may or may not converge. If it doesn't converge, for example, an, the sequence looks like this. 1 followed by -1, followed by 1, followed by -1. So this is a sequence of real numbers. And say bn is the following sequence. -1 followed by 1, followed by -1, followed by 1. So from here we can see that neither an or bn is convergent. In fact, because an is kind of oscillating between -1 and 1, so does bn. So from here we can draw the conclusion that an has two subsequences that converge to different limit points. So the odd subsequence converge to 1 because they are all ones, and the even ones are all -1s. So the other subsequence converges to -1. Same goes with bn. All right. So here we have defined this set E. What is this set? All the limit points of the sequence an. Right, this is our set. So according to the original definition, we take the infimum of this set and we call it, by definition, we call it liminf as n approaches infinity. So this sits in the middle of liminf. So liminf of an. Right? So again, let's recall the meaning of inf. What it means by infimum of a set E. So, for example, here I have for an, the set E is in fact all the limit points, that is just two elements, -1 and 1. So what's the infimum of E? What is that? -1, of course. In this case, we're lucky because we only have finite many elements in this set. So therefore, the infimum of this set lives in this set. For example, if we have another set, 0 and 1 open interval, in that case, the infimum of this set is 0. Because according to the definition, infimum means the biggest lower bound. 0 is a lower bound. It's also the biggest lower bound. Right? -1 is a lower bound. -2 is a lower bound. So on and so forth. Infinitely many lower bounds. But the most useful lower bound is the greatest lower bound. That is infimum, in which case it's 0 in this case. Right? Why is it the biggest lower bound? Because open interval. 0 is the biggest lower bound because if we increase it by just a little bit, epsilon, a little bit more, then it's no longer the lower bound. Why? Because we can find an element in here, in this set, an element that's less than this epsilon, right? So it's no longer a lower bound. So therefore, 0 is really the greatest lower bound. That is the infimum. Okay. So can I give you an example of where a sequence is divergent and also has infinitely many limit points. For example, infinitely many elements in this set. Right? Of course, I can give you, for example, the sequence of 1 followed by 2, then 1, 2, 3, 1, 2, 3, 4. You see the pattern, right? So this infinite sequence, it has infinitely many limit points. So a subsequence that's convergent to 1, because 1, 1, 1, so on and so forth. Also, another limit point, another subsequence that's convergent to 2, 2, infinitely many 2s. Another subsequence that's convergent to 3, 3, so on and so forth, infinitely many 3s. Right? So in this case, the set E that contains all the limit points is 1, 2, 3 forever. Right? In this case, what's its infimum? 1. What's its supremum? Right. Supremum of this set, we define it as the limsup of an, right? The limit supremum of an. Positive infinity. That is to generalize the real numbers. That's when we include positive infinity and negative infinity all together into the real numbers. Right? If you generalize the limit, right? Generalize supremum to positive infinity, right? Treat it as a special real number. Right? That's what I mean. An equivalent definition, that is, first we take the infimum of ak. K is bigger than or equal to n. So first, let me explain what that means. Infimum of ak, where k is bigger than or equal to n, by definition, it means the infimum of the set of an plus 1, so on and so forth. So here we have the set, contains infinitely many elements, right? By order, an plus 1, an plus 2, so on and so forth. Take the infimum of this set. We call it infimum of akk bigger than or equal to n. So an alternative equivalent definition of liminf is that first we take the infimum of this, then we take the limit. Take the limit let n approach infinity, right? So we can actually prove that so the limit actually exists if we extend the definition of the limit from finite numbers to infinity, positive infinity, negative infinity, right? Treat them as special numbers. Right? Limit actually exists. And we can actually prove that this definition, this infimum of this set is actually equal to the limit of this infimum. They actually equal to each other. Maybe I'll make a video in the future to prove it rigorously. But right now, let's just use the conclusion. So, and also, by the way, that's the reason why we write the limit infimum, limit supremum as like this. That's the reason. And also in order for us to prove this inequality, all we have to do is can we first prove infimum of ak plus infimum of bk, is it less than or equal to infimum of ak plus bk? As long as we can prove this, then we take the limit on both sides. Then they automatically hold true. according to the definition of liminf. Yeah? Alternative equivalent definition. So the liminf. Right, so by definition, this is equal to that. So equivalent. So here's my goal. Right? So first of all, this is easy to prove. This is easy to prove. But this is hard to prove. First, let's deal with the easy one. So how do we know that the combined take the inf is greater than or equal to separate, take the inf separately? How do we know that? First of all, I say, start with this, infinite. Maybe first let's get some intuitive understanding before we prove it rigorously. So intuitively, I can say that, like I said, I have the sequence one, negative, one, negative. Another sequence, negative 1, 1, negative 1, 1. Right, this sequence. So how can we perhaps infinite of AK? Before we use this let's use this original definition. Okay? All the limit points take its infinite. Right? So all the limit points of this sequence, right, nothing but negative 1 and 1. What's its infinite? Negative 1. Right? Also, for this sequence, infinite of all the limit points, negative 1. Okay? Right, negative 1, negative 1. How about this? What's their sum? Sum 0, 0, 0, 0. What's its? It's already converged into 0. Therefore, it's liminf. Liminf. All the limit point, nothing but 0. Liminf is 0. Right? Is negative 1, negative 1. Is it less than 0? Of course. Obviously true. Right? Or they may equal to each other. Right? In some cases, they may equal to each other. But this can never be bigger than that. Always less than or equal to. Right? An intuitive understanding of the right-hand side inequality. Let's just get some intuitive understanding. So another sequence. 1, negative 2, 1, negative 2, so on and so forth. All right? So according to the original definition, right, all the limit points take its environment. Again, all the limit points take its environment. Negative 1. All the limit points, we have two limit points, negative 2 and 1. What's its environment? Negative 2, of course. No, I want to, what do I want? I want to take the limsup. Limsup, so the supremum of all the limit points. Supremum of limit points of 1, negative 2, must be 1. Negative 1 plus 1, is it bigger than or equal to this bit? Add them up. Add them up. 2, negative 3. 2, negative 3. Add them up. Take the liminf. Right, all the limit points take the infinite. All the limit points, 2 limit points, 2, negative 3. What's its infinite? Negative 3. Right? Which one is bigger? Right? Is it bigger than that? Is this bigger than that? Yes, of course. Of course. Right? So that's a intuitive understanding. Of course, like I said, we prove it rigorously, right? So this bit, first of all, infimum AK, K bigger than or equal to N. So remember the definition, notation of infimum AK means infimum of this set, right? First of all, since it's a infimum of this set, which means it is the biggest lower bound, but in the end, it is a lower bound. At the end of the day, right? It's a lower bound anyway. Since it's a lower bound, so therefore every element should be bigger than this, right? So, AK, any K that's bigger than or equal to N. In other words, any element from this set is bigger than the infimum, right? Of course, infimum BK, BK bigger than or equal to, less than or equal to BK for any K that's greater than or equal to N. Add them up. Infimum AK plus infimum BK less than or equal to AK plus BK, right? Just treat it as the whole entity, CK, for example. For any K that's bigger than or equal to N, this inequality holds. Since the left-hand side is already a constant, right? That's a constant. So, any element from this set, AN plus BN as a whole entity, AN plus 1 plus BN plus 1. From this set, any element from this set is bigger than or equal to this constant. If I take the infimum on this side, should also hold. Why? Because this inequality is telling me that this constant is a lower bound of this set. So, since the infimum of this set means the biggest lower bound by definition, and this is a lower bound, which means infimum of this must be bigger than or equal to this one lower bound. Because by definition, like I said, infimum means the so here is the points from this set, all right? Here is the infimum. Infimum means the biggest lower bound, right? Biggest lower bound. This is a lower bound. Since this is the biggest lower bound, it must be bigger than any other lower bound, right? This is a lower bound. For example, a lower bound sitting here. And infimum of this thing sits right here. This must be bigger than that, right? So take the infimum K. So far what I've done, I've just did this on the right hand side. I take AK plus BK as a whole unit, whole entity. I forgot that. Then I take the infimum. Of course, infimum is the biggest lower bound. This is a lower bound. So biggest lower bound is bigger than any other lower bound, right? So this is automatically true. Like I said, I've proven, in other words, this inequality, right? Like I said, as long as I've proven this inequality, then I take the limit on both sides, right? Then this is true, according to the alternative equivalent definition of liminf, right? By definition, use this bit, right? Like I said, right-hand side is much harder. Right-hand side. Because limsup, can we prove limsup is bigger than or equal to something? I think that's easy, right? Because limsup means the lowest upper bound. It is an upper bound. Upper bound is bigger than or equal to something. It's easy to prove. Something will determine that. But liminf, can we prove it is bigger than or equal to something? That is not easy, right? We can prove liminf is less than or equal to something because it is a lower bound, right? Biggest lower bound. How can we prove it's bigger than or equal to something? Right? What could that be? Okay, that's the difficult part. Like I said, first, let's deal with the easy part, right? Easy part is easy. Can we show, can we first show the inf, the inf ak plus bk is less than or equal to infiniment of ak plus supremum of bk. Right, can we show that? If we can, then we take the limit on both sides, then this is automatically true. Right. Okay, like I said, first let's prove supremum. Because supremum bk bigger than or equal to something. Right? What is that? Any bk, change this into bk, any bk, k bigger than or equal to n, right? We already know that. Then we also know that infiniment of ak, by definition, infiniment of ak, like I said, it is the biggest lower bound. It is a lower bound. These are all the elements from this set, right? Infinitely many. This is a lower bound. Also the biggest lower bound. In other words, if it becomes a little bit bigger, then it's no longer a lower bound, right? So here is infiniment of plus epsilon, small epsilon, right? Then it's no longer a lower bound. There must be some element in here that's smaller than this, right? So plus epsilon. This element here is smaller than this, so this is bigger than that element. This element, right, sits right here, smaller than this point. This point is this, smaller than, right. For any epsilon, that's positive. So fixed capital N, all right? So for this fixed capital N, we say B sub N. Is it smaller than supremum bk? Of course. Because Bn is somewhere infiniment bk, Bn plus 1, somewhere in here. Of course, no larger than the supremum, of course, by definition. Then we can just do some interesting operation. This is bigger than that. This is bigger than, so add them up. Infiniment ak, k bigger than or equal to n plus epsilon plus supremum bk k bigger than or equal to n altogether bigger than an plus bn, right? Then bigger than or equal to what? Bigger than or equal to the infimum of AK plus BK, right? Because AK plus BK take its infimum, right? Infimum is the biggest lower bound. It is a lower bound. Therefore, lower bound must be less than any element from here. Right? This is obvious. So we don't even need the middle part. The middle part has finished its mission, no longer needed. All we need is left-hand side and right-hand side. Right? This is already bigger than that. Now, like I said, it is true for any epsilon that's positive. Now we let epsilon approach 0. Right? Now epsilon is gone. Right? This is totally legitimate, totally legal. Therefore, what do we have? Infimum AK plus supremum BK bigger than or equal to infimum AK plus BK. Right? Like I said, I've proven infimum AK plus supremum BK bigger than or equal to infimum of AK plus BK. I'm done. Right? Then we take the limit on both sides. We get. So far I've done proving both the left-hand side and right-hand side of the inequality. But there is another method proving the harder part, that is the right-hand side. Different method. Just as technical as the previous one, if not more technical. So here we're going to take advantage of the left-hand side. Suppose we already proved the left-hand side, the easy part, and we're going to prove the right-hand side now. So I'm going to still use this definition, right? Before that, I'm going to let AN plus BN equals CN. Then AN is equal to CN plus minus BN. Right? This is the key step. I'm going to express AN in terms of that. Infimum Cn minus Bn bigger than or equal to separate them. Right? Take the infimum Ck. Take the infimum negative Bk. Like this. Right? This is already true. Right? Suppose we know this part is true. And now, remember, Cn minus Bn just means An. So, infimum Ck, Bk, K. Infimum K, AK. Right, this time. So this time I'm going to claim that this is actually equal to negative of supremum BK. Right, this is true. Right? If this is true, I'm done. Now, first of all, how do we know that? How do we know? Infimum negative BK K is equal to negative supremum BK. Okay? So first of all, I treat negative BK as a whole entity, negative BK. K go from n to infinity. This is it. Right? To prove this fixed constant is its infimum, first we need to prove this constant is a lower bound. Second, we need to prove this constant is the biggest lower bound of this set. Right? First of all, why is it a lower bound? Because can we show that any element from here, is it bigger than or equal to this constant? Treat it as a constant, right? It's already a constant. Negative supreme bk. Right? First, I'll show this constant is one of its lower bound. Right? So for any k bigger than or equal to n, in other words, can we show multiply by -1 on both sides, change the direction, less than or equal to supremum bk? This is automatically true because supremum bk is supremum of bk is the supremum of this set, right? This element, so on and so forth. So supremum is the smallest upper bound. It is an upper bound anyway. So n upper bound is bigger than or equal to any element from here. This is automatically true. Right? This is true. Next, can we show that this is the biggest lower bound? Right? Biggest lower bound. So the infimum of, so here, negative supremum bk, already a constant. We've shown it is a lower bound. Right? This upper. So this a lower bound. Right? These are the these elements, infinitely many elements. We've shown this is a lower bound. Can we show if we increase it just a little bit here, then it's no longer a lower bound? Is there an element in here? No. These elements are from not here, but from here, including negative sign. Almost forgot. So, is there an element in here, negative bn, that's lower than this? So, this is in fact this number plus epsilon. In other words, can we show that negative supremum bk plus epsilon is bigger than this bn, negative bn? Can we show this is true? Fixed n, n is bigger than or equal to little n. In other words, can we show that multiply by negative on both sides? Negative gone, positive become negative, change the direction, negative gone. Can we show this inequality? Of course. According to the definition of supremum, what's the meaning of supremum? Supremum of bk, right? This is the supremum. Supremum means the smallest upper bound, right? These are the elements from here, right? All the elements, this is the smallest upper bound, right? If it's a little bit smaller, right, a little bit smaller, then it's no longer an upper bound. In other words, there must be some element here, Bn, that's bigger than this point. This point is what? Supremum minus epsilon, right? Supremum minus epsilon. Smaller than this Bn. Can we show this is true? Of course. Like I said, this is already the definition of supremum, right? The smallest upper bound. If it's a little bit smaller, then it's no longer an upper bound, right? Some guy here must be bigger than this guy. No longer an upper bound. So this is true. All right. And like I said, I've shown this is a lower bound of this, and also this is the biggest lower bound. Right? A lower bound, also a biggest lower bound. So therefore, this must be the infimum of this set, by definition. Right? So therefore, what do I want? I've proven my claim. Infimum negative bk equal to negative supremum of bk. This is true. Right? So now what do I have? Okay. What do I have now is that I can just copy liminf ck. Inf ck. Ck is what? ak plus bk. Minus supremum. Move this minus to this side. I change it to positive. So this infimum ak is smaller than infimum ak. Minus becomes plus. So plus supremum bk. Right? So again, I'm done. So infimum ak plus bk less than or equal to infimum ak plus supremum bk. Right? So I take the limit on both sides. Right, on both sides. Then this is true by definition. Right? First take infimum, then take the limit.